As you know, I'm Jenny Stewart, and today we're going to do a little learning activity together. I want to thank you all for coming because I know you're doing it on your own time, and I really do appreciate it. So, in basic algebra this semester, we've been solving equations for quite a while, right? No big deal. But how do you feel about solving equations with fractions?
Kill me now.
Okay, what if I told you there's a way to remove those fractions from the equations, getting an equivalent equation without fractions and solving that? Would y'all be interested in learning that?
Yes.
All right, so that's what we're going to do today. I'm going to show you how to clear fractions and equations. Okay? Before we start, though, I have given you two pieces of paper. The first one is about what our learning activity is. Our goals is learning to clear fractions and equations. And it's already going to use some things you already know, like finding the least common denominator, reducing fractions when you multiply, and solving equations. But you're going to learn this new concept of clearing fractions and equations. Now, those are the learning objectives of theirs as well, because you will be finding the least common denominator. You're going to multiply each term in the equation by the least common denominator. We're going to reduce the denominators, or the fractions, so all the denominators are 1. Solve the resulting equation so it doesn't have fractions anymore. And then I'm going to have a little learning activity that's a tic-tac-toe game, and you're all going to have to be able to win that game by being able to successfully clear the fractions and solve the equations. Now, you'll be able to do this based on this little mini lecture I'm going to do in a minute, and I have a reference example for you that has a step-by-step that I'm actually going to work on the board. Now, you will need to score proficient or better on the learning rubric. You can look at this learning rubric on your own, but this is how I will be grading the outcome of this exercise. Okay? All right, let's get started. The second paper is the example that I'm actually going to put on the board for you, clearing fractions. Okay? And I do that so that you all won't have to spend your time writing notes. You can just jot notes on the paper as we go, and you can concentrate more on what we're going to do. Okay? So let's take this example, which is 2/3 y minus 1/4 equals a negative 5 plus 5/6y. That looks pretty complicated, doesn't it?
Yes.
Yes. Okay, so basically what you need to know before we start is clearing fractions is a method that you can only use if you have an equation or an inequality. This does not work if you have an expression. So you have to have either an equal mark or you have to have an inequality sign. It doesn't work when they're just by themselves. When they're by themselves, you have to find the least common denominators and make them all the same denominator and work them that way. This only works with equations. Okay? So our first step is we're going to find the least common denominator of all the fractions in the equations. Now, we did this earlier this semester. Okay? So to find the least common denominator, we write down all the denominators big to little. So that's 6, 4, and 3. And we're going to do the prime factorization of each. Okay? So what's the prime factorization of 6? 2 times 3. What about 4? 2 times 2? What about 3? It's just 3. It's already prime. Okay. Now, the least common denominator is the smallest number that all of those denominators go into. It is never the smallest denominator if you have more than one fraction, it's never the smallest one. It's always the largest denominator or something bigger. That's the reason we start with choosing the prime factorization of 6. And this is where I'm going to build my least common denominator. So I'm putting my 2 times 3 up here. And then we go down to the next one and we compare. So does this least common denominator that I'm building, does it have a 2 as a factor already?
Yes.
It's already there. I don't need to do anything. It's already in common, so I don't need to put it there. Does it have a second 2?
Yes.
It does. Does this have a second 2?
Oh, no.
No, it does not have a second 2, so I need to take that second 2 and make it a factor. Okay? If the second 2 wasn't in common, the first 2 was. Right? Now let's go to the next one and start over again. Does this now have a 3 in it? Yes. So that's in common. So we've gone through all the denominators. We multiply what we have up here. 2 times 3 is 6. 6 times 2 is 12. 12 is their least common denominator. That means that 12 is the smallest number that 3, 4, and 6 all go into an even number of times. Okay? All right. So we have our least common denominator of 12, so I'm just going to erase this. All this is already on your paper. So the second step we're going to do is we're going to multiply every term in the equation by the least common denominator, which in this example is 12, right? So, remember, terms are what's between plus signs, and because we can say this is plus a negative 1/4, that's also a term. So this is a term, this is a term, that's a term, and that's a term, right? So all I'm going to do is multiply every one of those terms by 12. So this is 12 times 2/3 y plus, I always put a plus there because I'll get my negative when I get the number, plus 12 times a negative 1/4 equals 12 times a negative 5 plus 12 times 5/6 y. That's pretty simple, right? So we just took every single term and multiplied it by the least common denominator. Now I don't really want you to do that multiplication yet, okay? Because our third step, which I have to move over a little bit for, is we're going to reduce the fractions. I don't care so much about the whole numbers now, about the integers, because that's over 1. The denominator, that's a 1, and that's what I want. So we're going to reduce the fractions, so all denominators equal 1. Okay? What that just means is that we're going to divide each fraction by the denominator of that fraction. Okay? Now we know a whole number like 12, an integer, can be written as a fraction right there. Right? So I'm just going to go ahead and put these out here. It just makes it easier for you to see how to do it. So I'm going to divide the 3 out of both the numerator and the denominator, okay? 3 goes into 3 one time, 3 goes into 12 4 times. It's best to put a line through it so you know that it's gone and you have a new value there, okay? Then I have 4 goes into 4 one time, 4 goes into 12 3 times. I don't care about this one because it's already 1. So what do I divide this one by? 6. So 6 goes into 6 one time, 6 goes into 12 2 times. Do we see now that every single one of my denominators are 1? Mm-hmm. Those fractions are history. They're gone. Okay? So what are we going to do next? We're going to multiply what's left. In the numerators. Okay? And that's one of the reasons that you want to slash through it, because now you know what's left here. So I have 4 times 2y is what? 8y. 8y. 3 times a negative 1. 12 times a negative 5.
-60.
Very good. Negative 60. Plus 10y. Don't forget the y, right? It's very important when you're doing these that you see, because y is also y over 1. Yes? That you get the variables and also that you're really careful about the signs. Okay? Now, what do we have? This equation is an equivalent equation to this equation. This one doesn't have fractions. Which one do you think is going to be easier to solve? Much easier. These are like things we do all the time, right? All right, so now the last step is solve the equation. All right, so we know already to solve an equation, you add and subtract until you isolate. Yes?
Yes.
And I've told you I want you to always start with the variables first if you have variables on both sides of the equation. So I want to get rid of this 10y. It's a positive 10y. How do I make it go to 0? Subtract the 10y. So if I subtract 10y from this side of the equation, I have to subtract 10y from this side, right? Because what you do to one side of the equation, you do to the other. So this gives me a negative 2y minus 3 equals, that has gone to 0 because 10 minus 10 is 0 and 0 times y is 0. Just gives me a negative 60. I'm solving this for y, but it's still not isolated, is it? So I'm still going to add and subtract until I isolate. So I need to get rid of the negative 3. How do I get rid of a negative 3? You add it. So I'm going to add 3 to both sides. So this is a negative 2y. Those go to 0, so they're gone, equals a negative 57. Okay? Now, the term with the variables isolated. Yes?
Yes.
So that's the only time you divide. And what do we divide by? You divide by the coefficient, which is a negative 2. So if I divide out the negative 2 on both sides, y equals, what's a negative divided by a negative?
Positive.
So it's 57 over 2. Now, we would reduce this to lowest terms. Is the numerator even?
No.
So we know it can't be reduced because 2 doesn't go into a number that's not even. So our answer is y equals 57 over 2. Now, wasn't this much easier to solve than you think that would be?
Yes.
Yes. Okay? So, any questions? Now, of course, you'd want to check this. And to check, you would simply go back into the main equation, the original equation, and let y equal 57 over 2. Okay? So, now, we have a little learning activity we're going to do. Okay? And I want to give you the rules for the learning activity. Y'all remember tic-tac-toe?
Yes.
So this is a clearing fractions tic-tac-toe game. Okay? And you need to clear fractions to work the equations. And you can get 3 equations in a row correct, either vertically, horizontally, or diagonally. You're going to work in teams for this exercise, okay? So why don't we just take the teams that we're sitting next to. Now here's how we're going to do it. As a team, I would like you to pick an equation on the grid to work, okay? You both will work the same equation, okay? You will agree on an answer. Hang on, if you don't agree on the answer, you need to show each other how you got to your answer, and you decide between you which one you think is the right answer, okay? When you get your answer, you're going to bring me your paper, and I'm either going to put a green O if it's correct, or a pink X if it's incorrect. If you get an X on it, meaning it's incorrect, it's out of play. I will show you how to work it correctly before you go back and choose your next one, okay? But the goal is to get 3 in a row, and when you get 3 in a row, you win. Okay? I've allotted 20 minutes. I don't think it'll take that time, but why don't we start working on them now? Any questions? I think it should be fun. Of course, that's just me. Okay.